Hello, my name is Jason Kridner. I'm with BeagleBoard.org Foundation. We are a nonprofit company that makes single board computers primarily. We make computers to help innovate around embedded systems, right? Enabling the community of developers around embedded systems make things better. And we care deeply about open source. And as part of caring about open source, we care about open source instruction set architectures and open source hardware. So all of the hardware that we design, we release as open source. So you can get the source schematics, the layouts, all the details for all the hardware that we design, so that we can participate with our community. You can provide us real feedback. You can get real answers about the things that we go and create. So I don't know, this audience, I would expect you to already be really interested in RISC-V. For us, we care deeply about open source and the diversity of applications and solutions that RISC-V can provide while still providing, common binary infrastructure, software that can run on many, many different types of systems. So I'm going to show you two very different systems that we've created and that you can go and buy today and build solutions around using RISC-V. So the first is BeagleV Ahead. So this is a very high performance RISC-V solution, right? So this is a super scalar, multi-issue, out of order execution processor designed by Alibaba, their T-Head division, and they have released RTL for this C910 core, so you can get all information all the way to that level of your understanding of what's been created here. This also includes the 0.71 vector instruction set operations, right? So this is a 64-bit quad core running at 2 gigahertz, and we provided it in a BeagleBone form factor with the microbus connections, with onboard flash that ships with the Linux distro. We provide Yocto-based and Ubuntu-based distro images. You could also get Android for this platform. There's CSI connections, there's DSI connections on here, HDMI output, and gigabit Ethernet, right? All for about $150, and again, completely open source, so that you can look at the details. And we're continuing to get more and more documentation from T-Head. And if you look at all the other platforms, back here at the RISC-V, you'll see many different platforms using that same SoC, right? So it's a very common SoC, very broad user base of support. And recently, GCC 14 it now includes support for those pre-release vector instructions, allowing for very optimal code running on this RISC-V platform. So something very different than that. This is the BeagleV Fire. This features a microchip polar fire SoC. Also 64-bit quad core, right? But this is not out of order superscalar execution, right? This is a much more traditional or older style processor, right? But very reliable, right? So, and what's really magical about this platform is it includes FPGA fabric, right? So we give you the ability, so we ship with a Ubuntu distribution build and the onboard flash, and we provide on our openbeagle.org all the tools and examples that you need to rebuild the gateware inside the FPGA. So if you're just getting started working with FPGAs and you want to experiment, learning Verilog, learning to create things with FPGAs, this is a really great platform to get started on that. And you can use openbeagle.org to rebuild the gateware that's being shipped in the FPGA fabric, right? This is a flash-based FPGA, so you program the FPGA, and when you power cycle it, it just comes right back up to the state that you programmed it into, right? So the fabric comes pre-programmed, and it's very easy to go and get a new bit stream. And you don't have to get JTAG tools to reprogram this. You can reprogram it directly within the Linux environment and the platform itself, right? So you run the script, it reprograms the gateware, you reboot, and it's running your Verilog code in the FPGA fabric. And there's examples here for PCI Express on the M.2, so if you want to have high-speed wireless cards or NVMe storage on that, that's possible over the M.2 connector. There's also a very high bandwidth syzygy connector. And this SoC has very high bandwidth IOs with 12.7 gigabit per second SerDes connections on it, right? So it's very easy to get a lot of data in and out of this processor and use the FPGA fabric to process that in real time, and then use the Linux running on the hard RISC-V cores, as your interface, right, to the rest of your system, right? And you've got gigabit Ethernet, so you can, do data logging, do control systems, intelligent HMI, right, with the BeagleV Fire. So both of these boards are available through multiple distributors today, available each for about $150. You can check out the full design materials at openbeagle.org and find both of these boards on beagleboard.org.